All right, guys, today we are going to talk about identifying horizontal stretches and compressions as well as those reflections on the graph. So, first thing we're going to look at, and we're going to actually go to Desmos to look at these graphs. We can graph these in our graphing calculator and then see what is happening each time. So, our graph of y equals x squared, remember this graph looks like a U. All right, it's a parabola. And so what does this 4 and this 1 over 4 do to our graph of our parabola? So let's go ahead and click over to Desmos and let's look at that and let's see what happens. So we have x squared here. This is this graph, all right, the graph of x squared, and it's in green, all right? So I'm going to click on this 4x squared. And what I notice is that this purple graph for 4x squared is located inside of the green graph. So this 4x squared right here, this is going to be a vertical, right, a stretch of the graph. Okay, so this graph is kind of, it becomes narrower or skinny, all right? So this is kind of what happens when we have a positive 4 right there in front of the x squared. Well, what happens if we have something that's bigger than 1? I mean, excuse me, that's less than 1 instead of a number that is greater than 1 here. So what happens if we're a fraction or we're in between 0 and 1? So let's look at this 1 over 4. All right, and so this other line right here, you see that the graph got really wide. Okay, so this is a compression of the graph, compressed vertically. It makes everything wider. It's a horizontal stretch. It makes everything wider compared to this green graph for y equals x squared. So the fraction is going to make my graph wider, all right? So the whole number makes the graph narrower. The fraction is going to make our graph wider. Okay, let's go back and let's review some of this. So our parent function is y equals x squared. Then we're going to describe this graph for x minus 3 squared plus 6 on the outside. And so we remember from the previous lesson that this minus 3 takes our graph and shifts it to the right because the inside lies to us. All right, so this minus 3 is going to shift the graph to the right 3. This plus 6 on the end shifts the graph up 6 units. So we know that this general U shape for a parabola that goes through 0, 0 here for x squared is now going to be shifted 1, 2, 3 to the right, and 1, 2, 3, 4, 5, 6 units up. And so that's where it's going to begin, and it's still going to have that generic parabola or the U shape there. Okay, let's keep going. So here our parent function is x to the third. And now we have, instead of an understood 1 in front of that x to the third, we now have a 2. And so we know that this is going to vertically stretch our graph by a factor of 2. And our graph is going to be shifted down 5 units because of the minus 5 on the end. Okay, next graph that we have. So this negative in front, and we still have our 2, which is going to stretch our graph just like this previous one did. All right, but what does that negative do out front? So let's take a look at Desmos and see what that does. So our normal graph right here, or the parent graph, is x to the third power. All right, and so let's see what a negative would do in front of this. If I could type this in correctly, there we go. All right, so let's see what a negative would do in front of my x to the third. All right, it looks like everything that was on the left side gets flipped up. Everything in red on the right side got flipped down. So these are mirror images of each other. All right, so there's your first one, x to the third, and here is your second one, which is negative x to the third. And so let's look at what happens to our graph if we are going to put a 2 in the parentheses with the x. All right, so I'm going to close that parentheses, raise that to the third power, and you can see how that green is inside. All right, it's closer to the y-axis. All right, it's being vertically stretched, horizontally compressed. Okay, it's also inside the blue line down here. So the graph is getting narrower, it's getting skinnier, all right, for each value of x. Okay, so that's why we would say that this is reflected. This negative in front flips the graph, all right, and then our graph is horizontally compressed or vertically stretched. Okay. All right, let's also take a look at this. So this is our big picture. This is something that is really good to remember as we're going through these different problems. So if you have a negative out front, that's going to reflect our graph, all right, over the x-axis. Okay. This negative b on the inside is going to reflect our graph over the y-axis. Okay, we talked about in a previous lesson that plus c inside the parentheses, don't forget that the inside lies. All right, so a plus is going to move this to the left, a minus is going to move this to the right. We have this reminder here for horizontal movement. All right, the outside is going to deal with our vertical movement. All right, a plus is going to take the graph up, a minus is going to take our graph down. The last thing that we need to make note of is our vertical compression. So if this number in front is greater than 1, then we have an expansion or a narrower graph. And if a is less than 1, so a fraction in between 0 and 1, then you have a compression, meaning that this is going to be wider in the way that it's viewed on our coordinate plane for the graph. Okay, same thing here. All right, for our horizontal compression, so inside, if b is less than 1, all right, so in between 0 or less than 1, then we have a narrower compression, and if the reciprocal of b is greater than 1, then we have an expansion of the graph, or that it's wider. Okay, but the general rule of thumb is any number in front of my x squared or x to the third, all right, if this number is greater than 1, so if it's 1 or higher, then the graph is going to be narrower. All right, it's going to be vertically stretched. All right, if this is a fraction, all right, so 1 over a number, then our graph is going to be much wider than it was previously. Okay, again, let's look at a couple of more review type questions. All right, we have y equals x to the third, and we want to translate this 4 units to the left and 7 units down. All right, so to do 4 units to the left, we know that we need to have a plus 4 inside of our parentheses, and 7 units down, we have to have a minus 7 on the outside of our parentheses. So this would be y equals x plus 4 to the third power minus 7. All right, what if we also asked for a graph that is stretched vertically by a factor of 3. Well, to stretch this graph vertically by a factor of 3, we would have this for our equation. That 3 would come in front of the parentheses. All right, and then we would still have our same operations here. 40 units to the left, 7 units down. Okay, let's look at the difference between these two graphs. So we have x plus 3 squared and then x squared plus 3. Well, this graph, because it's inside the parentheses, this means that we're moving this graph to the left 3 units. And on the outside, remember outside is true, so this is up 3 units. Okay. Remember for your reflections, this minus sign in front is going to reflect over the x-axis. So let's look at just a couple of more examples before we try some of these on our own. Okay, so let's take a look at this first example. We're going to say our parent function is y equals x squared, and we want to, in part A, reflect over the x-axis. Okay, so to reflect over the x-axis, what we're going to need to do is add a negative in front of our x squared, so this is going to be negative x squared. And this would work. So anything that we have, all right, I'm going to actually put that in parentheses to show that we're making the whole thing negative here. We're not saying, there is a difference in negative parentheses x squared and y equals negative x squared. Because here, this is the exact same. A negative times a negative is a positive. So these two are not equivalent to each other. Okay, let's look at part B. Let's say that part B wants me to stretch vertically by a factor of 4. Well, this is going to put a 4 in front of my x squared, and so this is what we would have. Okay, part C, we're going to translate, all right, or move. We're going to translate the graph y equals x squared, 3 units to the right, 5 units down, and we are going to compress by a factor of 1/2. Okay, so again, let's go look at our compressions. All right, this is our big picture. Okay, vertical compression is when we have a fraction right here. All right, so we're going to end up making our graph wider. All right, so for this one, if I'm writing this out for y equals x squared, we have, I'm going to take care of 3 units to the right. So 3 units to the right is going to take place inside my parentheses. So this is going to be x minus 3. Okay, and all this is squared for x squared. And then our other piece, 5 units down, is going to take place outside the parentheses. So minus 5. And then a vertical compression by a factor of 1/2 is going to put a 1/2 out in front of everything. So this would be written as y equals 1/2 x minus 3 squared minus 5. So this would be shifted 3 units to the right, 5 units down, and compressed by a factor